Hope you guys are excited. This is your last formal section of calculus. After this, it's all AP review. Let's look at these. Let f of x be an antiderivative of blah blah blah. If f of 1 equals 3, find f of 5. What I need to do is rewrite this using the fundamental theorem of calculus. What I see here is I have my function, I have its integral here and here, and I don't care what its integral is, I just care what its value is. I have my lower limit, and I have my upper limit. So rewriting this using the fundamental theorem of calculus, I have the integral of my function evaluated from my lower limit to the upper limit, and that's equal to the antiderivative of the upper limit minus the antiderivative of the lower limit. So I have the integral of the upper limit minus the integral of the lower limit. And now what I do is I solve for the thing that I want. Here in this case I want to find f of 5, so all I have to do is take f of 1 and add it to the other side. So f of 5 is equal to the integral from 1 to 5 of the square root of 4x squared plus 5 plus f of 1. And now I can plug in numbers. I have a number for f of 1. I know that that's 3. And then to get this number, I'm going to go to my calculator and I'm going to numerically integrate that number. These problems always happen on the calculator portion of the AP test. So if I plug this integral into the calculator, which I'll show you how to do in the next segment here, I end up with f of 5 equals, that number from the calculator was 25.866, and I was given that f of 1 is equal to 3, and so my final answer is 28.866. And it's done. Note that f of x is the derivative of capital F of x, right? F of x is the derivative of capital F of x. So this type of problem could be written a lot of different ways in terms of derivatives and integrals and things, and antiderivatives, I should say. Let's look at this one. It says, suppose y prime of x is 2 tangent squared of x to the 4th plus 1. If y, notice there's no prime, of pi over 6 is equal to 0.5, find y of pi over 12. It's my derivative that goes inside the integral, right? And so using the fundamental theorem of calculus, I can rewrite this as the integral of 2 tangent squared of x to the 4th plus 1 evaluated from excuse me, the lower limit, pi over 12, to the upper limit, pi over 6, and that's equal to the antiderivative, or the integral, y of the upper limit minus y of the lower limit. And I can rearrange it, or I can plug in numbers. If I plug this monstrosity into the calculator, which again I'll show you how to do in a second here, I will get 1.454. This is very important. Whenever you're plugging trig functions into the calculator, make sure that you are in radian mode. You should always be in radian mode on the calculus test. You shouldn't have to do degrees ever. It is equal to y of pi over 6, it told me was 0.5, minus y of pi over 12, which is what I'm looking for. And then that algebra becomes very simple to do. I can subtract 0.5 from this side. I will get 0.954 equals negative y of pi over 12. And divide that negative over, and you get 0.954. The AP test always wants 3 decimal places. Okay. Now let's switch screens here and learn how to do all this in the calculator. All right, this is what you have been waiting for. How do I use the calculator to find integrals and derivatives? I'm going to show you all the secrets. I just want you to remember, keep it a secret from future calculus generations. They need to suffer the same way that you suffered.
Let's start with an integral. On the TI-84, this is the same as a TI-83 if you don't have the update. If you have the updated software, it just formats things nicely for you. So if you can handle it without the nice formatting, then you can do it on any of the calculators. I hit math, and I go down to number 9 here. It says FNINT, function integrate. And what I do is I'm going to enter the function that I want to integrate. Let's do the one from the first example problem. I want to do the square root of 4x squared plus 5. So I have my function, and then I hit comma, and the variable that I want to integrate with respect to. I used x in my function, so I want to integrate with respect to x. I could do any variable I wanted that my calculator will let me. So I have function, comma, variable, comma, and then it will not do this symbolically for you, not on these calculators. You have to give it limits of integration. And so I have comma my lower limit, comma upper limit, close my parentheses, hit enter, and there's that beautiful decimal right there. So remember, that is your function, comma, variable, comma, lower limit, comma, upper limit. This is really nice. Let's see what else the calculator can do. I can also, you see we passed right over it, in derivative. I can numerically find derivatives. Let's say I wanted to evaluate x squared, and I want to find its derivative with respect to x. And again, I have to tell it where I want to evaluate it. Let's say I want to evaluate that at 4. Let's think about what should happen. The derivative of x squared is 2x. If I plug in 4, that should give me 8. And there it is. And of course, we could do something more complex and get a decimal out of that. Other things that your calculator is very useful for, especially in this chapter, is finding points of intersection for two graphs. Whenever you're doing areas between two curves or solids of revolution, it's nice to know where those functions intersect. Right? So let's do an example. Let's say I graph x squared and let's say x plus 3. If I had to do this by hand, I'd set these two functions equal to each other and solve for x. But let's let the calculator do it for me. There's x squared, there's x plus 3, and I want to find these points of intersection here and here. So I can go to second calc. Got lots of nice things here. I can find zeros. That works nicely for quadratics if you want to find where it crosses the x-axis. I could find the minimum of that quadratic. If it was flipped over, I could find its maximum. Here's what I'm interested in, the intersection. It's going to ask you for the first curve, and you see I can scroll around from left to right. There's 1. And it's pretty nice about choosing the second curve. I can scroll around if I want to. And I hit enter, yes, I want to guess, and it finds that point of intersection for me. It gives you the x-coordinate and the y-coordinate. If I wanted to find the other intersection, all I have to do is scroll to the left of it. It'll generally choose the intersection that's to the right. So here I'm going to go to the left of this one, left of this one, yes, I want to guess, and there's your other intersection. Lots of nice things here on the calc section. Looks like we can find derivatives, looks like we can find integrals. Play around with these things, see what all your calculator will do for you. It's a fantastic tool. When you are allowed to use it, use it. Don't do anything by hand that your calculator can do for you. You need that time to spend on something else.